Mendeleev and about 6 months later, Meyer, elements were arranged by their chemical reactivity in groups or families. That's our columns. And we're going to see they were arranged in increasing energy in their rows or periods. Mendeleev and Meyer recognized that there was missing elements and space was left to accommodate the yet to be discovered elements on the table. So we will see that the elements are arranged in increasing atomic number, that's the number of protons, but the scientists back then arranged them in increasing atomic weight. There's slight modifications that's been done to the table since it was first developed. We have a IUPAC, International Union of Pure and Applied Chemistry, IUPAC, naming and numbering system. And the 1 through 18 on the periodic chart is the IUPAC numbering system. We also have the Roman numerals that is showing Roman numeral 1, 2, and we have A and B for the Roman numerals. And we start from 1 and go up to 8. And you'll see that happens with both the A and the B notation right here. We have columns in the periodic table, and that is going to be our vertical area here. If you are an element in a column, you do the same type of chemistry. We also have the horizontal part of the periodic table, and these are rows, the horizontal rows we call periods. So groups and family, or families. Are the vertical, similar chemistry. Rows are also called periods, are arranged in increasing energy. We'll talk a little bit about that later on. We also have a couple other main blocks that we can look at the periodic chart here, table. The first 2 columns and the last 6 columns are called main group or representative elements. So representative. Or also main group. The group that is sandwiched between these representative or main group elements are called transition elements. The transition elements are these in the middle, and the ones down at the bottom are called inner transition. The transition elements in the middle from iron on used to be called heavy metals. So elements that were from iron on in this, and now we call them transition elements. So we've discussed our groups or families, or the row or period, representative or transition. And when we look at the periodic table, we'll see both Roman numeral notation used for our columns, and we will see the number only notation, 1 through 18 on our columns. So several of these groups or families have special names, and these are called the alkali. Alkali mean base elements. We're going to see the lithium, sodium, potassium, etc. are all metals. And we have one non-metal, which is our hydrogen here. The second row, starting on the second row, we have the additional group, and this is called the alkaline earth metals. The alkali elements or metals are very reactive. The alkaline earth metals are slightly less reactive. We also have the coinage metals here. The coinage. That's our copper, silver, gold. And then on the right side of the stepladder line, which separates metals from nonmetals, we also have the halogen family. And we have this very unreactive family called the noble gases. Whereas noble gases are very unreactive, the halogen family is very reactive, similar to the alkali metals. Here are a couple of examples of the intertransition elements. Not only uranium is part of that group, but here is curium and neptunium. We discussed the alkali metals or elements, the alkaline earth elements or metals, our halogens, and our noble gases. Okay, when we talk about this stepladder line, our metals are on the left side of the stepladder line. So elements that are metals are on the left, and elements that are non-metals are on the right. All our metals at room temperature and pressure are solids, except for one, which is mercury, and mercury is a liquid. The inner transition elements are also metals. Nonmetals, on the other hand, can be solid, liquid, or gases. Noble gases family are all gases. Nitrogen is a gas, oxygen is a gas, fluorine is a gas, and chlorine is a gas. One nonmetal is a liquid, and that's bromine. So bromine is a liquid, just like mercury is a liquid. Only mercury is the metal, and bromine is a nonmetal. All the other nonmetals are going to be solids that are noted on the periodic chart. We also have metalloids. They have properties of metal and nonmetal. And our metalloids sometimes include boron, depending on your textbook that you might be looking at. But if a metalloid is on the non-metal side, it behaves more like a non-metal. If it is on the metal side of the stepladder line, it behaves more like a metal. It has properties of both non-metal or metal, and depending on which side of the stepladder line will depend if it has more similar to non-metal or metal properties. So here are some further examples of metal. Metal conducts heat and electricity. Think of a frying pan on your stove. If you turn on your burner, it easily will heat up the pan. They also have a luster or a shine. Metals are malleable and ductile. They can be pounded into thin sheets or drawn into wires. Again, all are solids at room temperature and pressure except for mercury. And here's an example of iron as a metal or potassium as a metal. Nonmetals, on the other hand, do not like to conduct heat and electricity. They are not malleable and ductile. If you take a diamond and you smash it, it shatters rather than going into a thin sheet. They could be a solid, liquid, or gas. They have lower melting points. And a couple of examples are nitrogen and bromine. Now with our nonmetals, remember we have diatomic molecules that we also have discussed. So elements that hang out in groups of two, one would be hydrogen, then our nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. These are all our diatomic molecules. And in the elemental form, there's 7 of them, and they hang out in groups of 2. This elegant periodic table of elements has so much information in it that if we can just decipher parts and understand where things are found and how they behave, will stop you from having to memorize a bunch of information if we can just look at the periodic table and understand how to use it to our benefit.